when human experts play or use expert AI, they learn new moves, new ideas that they wouldn't necessarily have thought of otherwise, which is going to take us forward in terms of learning. I'm going to actually start with a Turing test of sorts. So I'm going to play you two pieces of music. One of them was written by a person, and the other was written by a computer. And I'm going to ask you to tell me which you think is which. So here are the two pieces of music. Here's the first one. That's one, and then here's the second piece. So there we go, two pieces of music, one written by a person, one by a computer. So I'm going to ask you, put your hands up if you think the first piece was the one written by a person. Hands up now. Okay, quite a lot of people. And hands up if you think the second one was the one written by a person. Okay, I mean, I can't see at all, but it looks about 50-50, which is actually what I usually get for this. So I can tell you that the first one was the one written by a person, so well done to those of you who got that right. Second one was written by our technology at JukeDeck. Now, the idea of computers writing music is something that goes back further than you might think. Ada Lovelace, in her notes on the sketch of the analytical engine, said this. She said, "The engine might one day compose elaborate and scientific pieces of music of any degree of complexity." This is the mother of modern computing 150 years ago, saying that computers would one day write music. And what I'm going to do is I'm going to take you through 5 ways in the last 50 years that people have tried to fulfill this vision. And there are different ways you can do it. So the first way is by using rules. Now, music is full of rules. This is why when you listen to any famous pop song, it usually uses the same 4 chords. You can see why you'd think this would be appropriate. And actually, one of the first examples of algorithmic composition that was recorded was in the 1950s when Hiller and Isaacson composed a piece called the Iliac Suite. I'm going to play you one of the movements. This was composed by a computer using rules. So not amazing, but a good start in the 50s. And this is the first example of a commercial application of computer-generated music. This is an advertising campaign by the computer company Burroughs, where they got a rule-based system in the 50s to actually write this piece of music. The problem, though, with rules, as I'm sure you can imagine, is that basically it turns out quite quickly that the music theory books don't contain all the rules you need. No one really knows what it takes to write good music. So rules don't work in and of themselves. So then you have another technique, which is to use grammars. Now, you can see why grammars would be good for writing music. Grammars are about hierarchy, and music is about hierarchy. You have the overarching phrases, and you have kind of detail within those phrases. And people have tried this, and it's worked surprisingly well. Actually, one of the best examples of computer-generated music there's been was almost a grammatical approach. It was David Cope, his experiments in musical intelligence that he started a while ago. And what he did, he came up with an idea called recombinancy. He basically built a system that could read pieces of music, could basically break them down into their constituent elements and recombine those in novel ways. He did it so well that he fooled musical experts that he'd found new pieces by old composers. Here is a piece made by his system to imitate Bach. As a fan of Bach, I can tell you that's really, really good. Another thing that people have tried is using Markov chains. Now, Markov chains, as many of you may know, are systems in which the next state of the system depends only on the current state. You can see why this would be appropriate in music, right? The next note depends on the previous note. And people have tried this to very good effect as well. A great recent example is Francois Pachet's work. This is his continuator that learns quickly from the style of a musical player and learns to continue in that style. Here's a video of it in action. There's no video, but this is the person playing. Oh, there is. It's not on my screen. And the computer learns and continues that style so much that it surprises the musician playing, which is pretty amazing. The problem with Markov chains is that if you just base the next note on the single previous note, then it doesn't really have a very good idea of the context of the music and kind of meanders a bit aimlessly. But if you base it on lots of previous notes, it has too much idea of the context and ends up kind of copying what you trained it on. But they work very well. Fourthly, you have evolutionary algorithms. These follow the ideas of evolution, and you basically have a changing candidate set of pieces of music that you continuously you review, you choose the ones you like, and you reproduce those with variation. This is something called Darwin tunes that came out a few years ago in London. I'll play you it first before it's evolved. This is how it starts, not very musical, but then after lots of evolution, it gets to this kind of stage. So that's music, the ability to write music evolving, which is, I think, amazing. The problem is it takes humans to judge that music. There's no fitness function for music. We don't really know what makes good music, which makes that quite a slow process. And I want to now talk about what we're doing at DukeDeck, which is we're using artificial neural networks. Now, lots of you will have heard lots about this at Slush, I'm sure. Just to give you a quick overview of how these work, they're used, for instance, in image recognition. So if you want to train a system to learn how to identify a face in an image, you set up a neural network that's basically a series of connected nodes that's meant to symbolize the neurons and synapses in the human brain, right? Then you show it an image, you pass that in, it sets off a chain reaction along the synapses, and you get an output at the other end, a yes or a no answer. Now, the first time you do that, it's going to be basically random. But if you go back over those connections and re-weight them, and you do this enough times, it gradually learns the ability to be able to tell you whether or not there is a face in that image. And we do that with music. So we show it short snippets of notes, and we train it to be able to tell you what note it thinks should come next. Now, it's evolved a lot over the years, our system. This is what it sounded like back in 2012. And then by 2014, it was sounding more like this. And then more recently, we've started creating piano music that sounds like this. So we think that computers are starting to be able to write decent music. And today I actually just wanted to announce one thing we've been working on recently, which we think is very exciting. So like most people, we've been focusing mostly up till now on the composition, on how you get a neural network to write notes and chords. When it comes to actually playing that music, you generally get a performer to play it or use traditional methods like virtual instruments. But our amazing team back in London have been working on a system that actually uses neural networks, trains them to actually produce sound itself. So actually trains them to learn how to make the sound of a piano. What this means is, in the example you're about to hear, everything from the conception of the notes and chords to the production of the actual sound of the piano that you'll hear, the entire thing is formulated only in essentially the minds of neural networks. Now, you'll probably think it doesn't sound as good as the previous example. It doesn't, but it was made only with neural networks, which we think is pretty exciting. So there we go. That's what we've been working on recently. Now, some of you are probably wondering, what does this mean for the future of creativity? And the first thing to mention is that creative AI, of course, isn't only in music. This is a poem that was submitted to and published in a literary journal in the US in 2011 without the publishers realizing that it was actually written by AI. This is one of many pieces of art that you might have seen recently that was made by AI. This is actually by Harold Cohen's program called Aaron. This is an entire cookbook of recipes made by IBM's Watson, which I can tell you firsthand are delightful. And this is, of course, AlphaGo, where you might not think that Go is creative, but of course, if you look at moves like this, which is move 37 of game 2, and you realize that Lee Sedol, when he was playing AlphaGo, actually had to leave the room. He was so bowled over by this. These are things that are being creative. Now, some of you might think, well, this sounds like the end of art. And I would say to you that I don't think it is, for a couple of reasons. I think art is safer than most industries of being replaced by computers. Why? Well, firstly, art is about more than just the work itself. My favorite pianist is a guy called James Rhodes. Now, I like him because he's an amazing pianist, but I also like him because he has an amazing story. He overcame huge challenges to get where he is today. When we appreciate art, we don't just appreciate the piece of art itself. So I think that musicians are safe for this reason. But I think the other important thing is that ultimately, people will never stop being creative. Now, when AI can drive trucks, I don't think there are going to be many truck drivers left on the roads. But just because I'm not the best composer in the world doesn't mean I stop composing. Hans Zimmer doesn't mean I don't write any more music. And in the same way, when AI can write music, I don't think it's going to stop people being creative. We always will be. But it's all very well to say, why is this not a terrible thing? But it's also important to ask, why is it a good thing? And I think there are a bunch of reasons why creative AI is going to be an incredible force for good. The first is very simple. There's going to be way more art in the world. And in my book, this is only a good thing. But this is related to a second point, which is that it's going to make art cheaper and more accessible. And this is important not just because art is nice, but because art is economically useful. Music is used in videos, like our software. Images are used in articles. The output of creativity is economically useful. And at the moment, most people don't have the capability to make that. Creative AI is going to democratize the creation of this kind of thing. And I think it's going to be a powerful force for good in that respect. I also think that ultimately it's going to mean art is personalized. At the moment, you will hear the same music on opposite sides of the world. But with creative AI, there is no reason why millions of people should listen to the same 10 songs. Music and other art will be able to be personalized to your surroundings, to your preferences. It's going to open up whole new avenues of ways of experiencing art, which will, I think, be an amazing thing. And it's important to note that I think, as we've already seen, it's going to make people more creative. There was another Go player who played AlphaGo a few months before Lee Sedol did. He lost as well. And he had this to say after the game. He said, I lose, I study the game, and maybe I change my game. I think it's a good thing for the future. When human experts play or use expert AI, they learn new moves, new ideas that they wouldn't necessarily have thought of otherwise, which is going to take us forward in terms of learning. But where this stuff gets really exciting, I think, is where you look outside of art, right? Because creativity isn't just isn't just about art. It's the source of ideas. It's the key to problem solving. You look recently at the fact that IBM have announced that they're going to try to get Watson to figure out why Italians have such high life expectancy. You look at the fact that DeepMind have said that the whole point of what they're doing is to use their tech to solve the world's biggest problems. How do we solve climate change? How do you feed billions of people? How do you reconcile the quantum world with general relativity? These problems are problems that are currently totally defeating us. And there's a strong argument to be said that when AI can have its own ideas and can help with problem solving, it's going to help us in a huge, huge way. The idea of creative AI might make some people, and does make some people, uneasy. But I would leave you with a thought from Sam Harris, who said, the only thing nearly as scary as building an artificial general intelligence is the prospect of not building one. We have some huge problems facing us in the world today, and we should all be striving, I think, for a world in which there's more creativity, more good ideas. Creative AI isn't something to be feared. It's something that will take us to that more creative world. And I think for that reason, it's very exciting. Thank you very much for having me. It's been a pleasure.